Hey guys, I feel awful that I'm not going to be here tomorrow, but I've been trying to get this doctor's appointment for a really long time, so I have to take it, but I've made some problems similar to ones on your quiz to go over and make sure you're really ready for this. So, first thing we're going to do is take the derivative of this, and this is the chain rule. So we're going to do the derivative of the outside, leave the inside alone, times the derivative of the inside, which is the quotient rule. Bottom times derivative of the top is 0. Minus top times derivative of the bottom all over the bottom squared. Now that part's not so hard. The hard part is understanding that this is going to be multiple choice, so you have to be able to find the correct answer. So let's just do a little bit of manipulating here. This becomes -2, and when I multiply by that -3, I get 6 times 1 over 2x minus 5 to the -4 times 1 over 2x minus 5 squared. Okay. This one, you could do the quotient rule. I'll do that first. So bottom times derivative of the top is 0, minus top times derivative of the bottom, which is the chain rule. And remember, this is 2x minus 3 to the 1/2. So it's 1/2, 2x minus 3 to the -1/2 times the derivative of the inside, which is 2, all over the bottom squared, which is 2x minus 3. Now again, we have to simplify this. 2 times 1/2 cancels out, so you end up with -4. And then if I move this down to the bottom, I end up with 2x minus 3 times 2x minus 3 to the 1/2. But since these are common, I can multiply them together and add the exponents. So I would get -4 over 2x minus 3 to the 3/2. You also could have done this by moving, I'm going to do it down here, the denominator up and giving it a negative exponent. So this is the same as saying 4 times 2x minus 3 to the -1/2. And then the chain rule would be derivative of the outside is -1/2 times 4, which is -2. Leave the inside alone. Subtract 1 from the exponent times derivative of the inside, which is 2, which again gives you -4, and if you move that down, you get 2x minus 3 to the 3/2. Same answer that we got up here, two different ways to get it. Here's the chain rule again. Take the derivative of the outside, leave the inside alone. I'm going to put a 1 there just for show. Times derivative of the inside, which is 6x. Derivative of sine is cosine, so minus cosine x. That's it. And then here, quotient rule, bottom times derivative of the top. I'm going to put a 4 out in front. Minus top times derivative of the bottom all over bottom squared. So simplifying, that would be 8x plus 12 minus 8x plus 10 all over 2x plus 3 squared. So the 8x's go away. 12 plus 10 is 22 over 2x plus 3 squared. All right, so now we have the product rule. So first times derivative of the second, but this is going to be the chain rule because there's a number in front of the x. So the derivative of sine is cosine, leave the inside alone, times derivative of the inside. So that's first times derivative of the second, plus second times derivative of the first. So let's simplify this. We get 4x cubed cosine 4x plus 3x squared sine 4x. Okay, so I think there's 14 questions on your quiz, and there's 5 of them basically. That's how you do it. A couple other things on your quiz. Understanding that when, this is what Megan asked for yesterday. Let's talk about position, velocity, acceleration. Okay, this is f of x, f prime of x, f double prime of x. When the particle is moving right, the position is increasing. First derivative is positive. We don't know anything about the second derivative when that's happening. If it's moving left, the position is decreasing. First derivative is negative. If the position is concave up, second derivative, we don't know anything about the first derivative, second derivative is positive. If it's concave down, second derivative is negative. What else? If the velocity is increasing, then the acceleration is positive. If the velocity is decreasing, acceleration is negative. So we might not know anything about the position, but if the velocity is increasing, then this would be positive. I mean, we would know that it's concave up, but we don't know if it's positive or negative. And here we know that it's concave down, but again, we don't know if it's positive or negative. So that's pretty much everything you need to know. When something is at rest is when the velocity equals 0. And if there's any questions on Khan when you're reviewing that give you 3 functions, and you have to analyze which is the function, which is the first derivative, which is the second derivative, make sure you practice those because there is one of those on your quiz as well. Okay, happy studying.